Good afternoon, everyone, and welcome to today's webinar, Designing with Adhesives. Before we begin, I would like to go over a few items so you know how to participate in today's event. You have joined the presentation listening using your computer speaker system by default. If you would prefer to join over the telephone, just select Telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's call. I would now like to introduce Mike Shanahan, Market Development Director.
Thanks, Christy. No. I'm just waiting for the slides to catch up. All right, we now have liftoff. Thank you, everybody. Good afternoon, or good morning to those of you on the West Coast. Today, we'll be presenting to you Designing with Adhesives. My name is Mike Shanahan. I am a Market Development Director, and my colleague Daryl Small was an application engineer. We both have equally, I think, about 25, 26 years with the company, and so all with the general industrial adhesives business for Henkel. So in our next 45 to 50 minutes or so, we'll be going through the following agenda, and then we'll also open it up at the end for questions, as Christy had mentioned. I thought I'd give you a brief background on who Henkel is to get an appreciation for our expertise in adhesives and sealants. And then we'll segue into why one would use adhesives for an assembly option, and then give you a few examples of where adhesives are used today. And then we'll segue over to some basic adhesive terms. I would call it Adhesive Science 101. And then we'll segue over to Daryl, and he'll continue with different joint designs, the types of adhesives that are available in the market for you as options to design your assemblies with, and then certain types of criteria that one would go through to select the proper adhesives for their assembly. And then also just give you some helpful adhesive resources that Henkel has out there to make your selection process and design process easier. And then again, we'll open up for questions and answers. So first, who is Henkel Corporation? We are based, our global headquarters is based in Dusseldorf, Germany, and we started the company in 1877, just over 100, or about 140 years ago, and we have grown to almost 50,000 employees worldwide, of which we have about 6,000 employees here in the U.S. Approximately 16.5 billion euros. Those are 2014 numbers. We're a publicly held company, so we haven't reported our final numbers yet for 2015. We operate in about 120 different countries. We have almost 170 manufacturing facilities across the world. Here in the U.S., about 45 of those 169 are based here in the U.S. And we have 17 major R&D facilities with chemists and engineers that formulate adhesives, 3 of which are located in North America. We have 3 primary businesses for Henkel Corporation. On the consumer side, we have laundry and home care. You would be familiar with it most likely through Purex, but also Persil, which is the leading brand over in Europe, which they are launching here in the U.S. You may see some TV ads for that. Also, beauty care, hair care products. Got to Be is a hair care product we have in the U.S. Dial soap, Right Guard deodorant, our other brands you may be familiar with, and then of course adhesives, and that's our industrial business. So you may be scratching your head, well, what the heck do those first 2 products have to do with adhesives? And actually, a little interesting story. Back in the early 1920s, right after World War I, a lot of raw materials were scarce. Henkel was making their detergents, and they were purchasing an adhesive which they could no longer get in the market, so they formulated their own. And it was so successful, they started selling it to other consumer good manufacturers and then to industrial markets, etc. And since the 1920s, they've now grown that business to approximately 8 billion euros to make us the world's largest adhesives company. And we have presence in all the major segments of which adhesives are used in industrial and consumer businesses, which are about 50 different segments. Daryl and I, I should back up. Within the adhesives business, we have several different business units that specialize within each market segment. So we have an automotive and transportation business, a packaging and consumer goods business, aerospace, electronics. Daryl and I are with the general industrial, which is essentially all else, which is about 800 other segments across North America. And that is predominantly where the LOCTITE brand is used, as well as some other hot melts like Technomelt and Bondurite surface treatment technology, because we also have a functional coatings business. And our value proposition, where we really demonstrate value to the customer, is partnering with our key OEM distributors, along with our salespeople and the customers, in developing and engineering the best solution possible for their assembly and manufacturing process. And it's primarily focused on the solution, not on the product that's going to help solve the customer's problem. So before we get started into the next section, we thought we would be interesting to gauge everyone's experience with adhesives. So you should see a pop-up a radio button on your screen now. You can just click which one of these best describes your situation. Whether you've used adhesives before, you're considering switching to another adhesive, you use some adhesive but looking to integrate into your design adhesive, your design process. You already use a great deal of adhesives in your design process, or you're unhappy with your current product and you're looking for a better solution. And then finally, none if you are attending for education reasons only. People. All right. Results are coming in. We'll give it a little bit more time. Okay, Christy, probably enough time.
So we got all of the results in. It looks about 33% have used but are looking to integrate. 25% already use a great deal in their design process. 9% are unhappy, and 33% currently use nothing and are attending for educational reasons.
All right. Well, we have a good cross-section of different experience levels, so good to know. So why would one use adhesives? There's a variety of joining methods available, from welding, soldering, bonding, to as well as you can design your parts to create an assembly, whether you use pins or keyways or spline shafts to attach your parts. And then there's obviously permanent forces such as magnetism or threaded joints, press fits, etc., and also combinations. And adhesives are becoming more and more common for a joining method, whether it's used in and of by itself as a primary attachment method, or in a combination, whether it's be with a press fit or with a rivet or spot weld, etc. So they are becoming more and more popular. We'll go quickly through some of the benefits of why you use an adhesive, and then talk about some of the limitations as well. One of the biggest advantages of adhesives is that you can join dissimilar substrates, whether it's you're bonding plastics to metals or crystal to metals that you see in this culinary application, or ferric magnets to zinc dichromated steel, as you can see in this motor bonding application here. So that's one of the primary benefits of using an adhesive. Also, adhesives distribute stress evenly across the entire bond area. And that will create a much stronger assembly oftentimes compared to mechanical fasteners. And with mechanical fasteners, when you have, for instance, in that nut and bolt there, when there's force applied to that part, the stress is concentrated right at that nut and bolt assembly. And that's often where the substrate will start to fail if there is substrate failure. Adhesives also fill large gaps. This is an example really of a potting application where you're filling the gap on the hammer, but this is really just to demonstrate that adhesives can cure through significant gaps between parts. Also, it kind of goes hand in hand with adhesives. They not only bond, but they also seal to prevent any corrosion, moisture, leakage, etc., of whichever fluid you're trying to seal. This is a cross-section of an oil filter, and in the crimp there where it's curled around to join the bottom portion of the filter, there's an adhesive that's used to help increase the strength but also to seal. Aesthetics is another benefit of adhesives. You can much streamline your parts without having any bolt heads or rivets or spot weld marks, burns, etc. Where you can use adhesives much more streamlined, aesthetically pleasing, and so that's a very popular benefit. And also lightweight. Mechanical fasteners adds much more weight than adhesives does. I think one of the more popular ones you've seen in the press in the last 12 months or so is the Ford F-150. A lot of the literature I've read, by converting to the aluminum on the body, they were able to reduce the total weight of the F-150 by 700 pounds. And a large attribute of that was because they were able to use adhesives to help them reduce their weight as well, to help bond aluminum to the steel frame. And also adhesives can be easily automated. So not only do they perform out in the field, but within the process of some of your parts you need to take consideration. And Henkel offers a whole line of LOCTITE dispensing and curing equipment, which you can get through Hisco as well. So some of the limitations for adhesives, number one, you need to convert from a liquid to a solid, so you need some way to cure it. Oftentimes there are adhesives that will, they will cure on their own depending on the chemistry that you're using. Sometimes they need to be initiated with to cure, whether it be by ultraviolet or visible light, heat cure, etc., or you can have a catalyst added to it. But Daryl will get into that when he talks about the different types of adhesive chemistries that are available and the pros and cons of that. Also, related to curing is fixture time. You need to wait for your parts to fixture. Unlike a nut and bolt, once you torque it down, you can, it's readily movable. The adhesive, you have to wait for it to set or to fixture before you can move your part. And that's what we refer to as fixture time. And you can get adhesives that are fast fixture as just a couple seconds, or some may require minutes, if not tens of minutes for it to fixture before you can handle your part. They also can be messy, having two parts, having to mix two parts together. Sometimes if you have a two-part adhesive, you need to come up with a proper way of handling that in your plant. So equipment plays critical part. And then another reason is it's a chemical. And with chemicals you have safety considerations, so sometimes that can be a concern depending on the type of adhesive that you are using. And then also, adhesives are sensitive to part cleanliness, so oftentimes with as-received parts you have to treat them with some type of cleaning process before you can use the adhesive, and obviously that can be a nuisance, but easily manageable if you work with your representative coming up with the best process for you. And this is the holy grail of adhesives is when we do group training, oftentimes we'll ask the questions, what's, describe an ideal adhesive, and the response is often adhesives that will be as strong as you need it to be, but until you need to get it apart, you want it to be very easy to disassemble. And we haven't yet invented that adhesive yet, and that's one of the challenges with adhesives. Oftentimes you have to destroy your part in order to get it apart. Or use some type of heat if your parts are robust enough to handle it. So we have our next polling question, and the question is there opportunity to improve your adhesive, sealant, coating, and manufacturing process? All right, thanks, Christy. We have our answers. You can see a majority of people are not really sure, but open to investigating better processes. So what better place to be today than to be here with us talking about adhesives. So where are adhesives used? They are used, all over the industry in a variety of different places. Here are just a few examples. From the consumer electronics industry, loudspeakers is a big business for adhesives, bonding the voice coils to the cones or the magnets to the frame. Adhesives revolutionized the loudspeaker industry probably about 35 years ago and has been a major assembly option for them ever since. Automotive industry, as I mentioned, the Ford F-150 was just one example, but the automotive industry uses adhesives quite frequently. Filtration industry, air filters, oil filters, blood filtration. The medical device industry, there you were showing a needle bonding application where you're bonding the stainless steel cannula into the plastic hub. Those all use adhesives. Also, handheld device use adhesives extensively throughout the assembly. Sporting good industry, Ping, for instance, is a good customer that uses a LOCTITE product of bonding the club heads to shafts. The appliance industry, aerospace, LED lighting is a growing industry. And then finally, in a market that I specialize in, the specialty vehicles, dry freight trailers, work trucks, they are used extensively throughout that industry as well. Some specific examples. I'll go through 3 different application case histories, and I pulled these out of my portfolio of specialty vehicles that I manage. And we had one customer on the left, a beverage truck on the rear wall. That was a pretty extensive labor process in order to get that rear wall attached. And, excuse me one second. They had to, they were assembling the walls to a aluminum frame, and they had to pre-drill each one of the holes in order for the rivets to be assembled in place. And then they would put as you can see the red arrow, they have a white plastic cover that went over the rivets on the outside. And that would be put on there for aesthetic reasons, so you wouldn't see the rivet heads. But they would have problems with those rivets corroding and causing the paint to peel. And also, again, it was extensive labor. So they used our LOCTITE H8000, which was a structural MMA or methacrylate acrylic adhesive on the front and rear exterior walls. And this allowed them to simplify their process, going from 6 hours down to 4 hours, so roughly 33% reduction in process time. But also, you can see in the bottom, it improved the aesthetics. They were able to get rid of the rivets, get rid of the white plastic rail, and have a much more streamlined looking trailer, and also lighter weight. And they did not have any leaks or corrosion as a result of that. The middle one is a box truck where they're assembling a logistic rail through the FRP sidewalls. And again, there they had the bolts of which they had to pre-drill. They had 2 operators, one on each side, that had to use those lag bolts to attach the logistic or E-track rail to the side of the wall of the box truck. And in lieu of that, now they go with our LOCTITE H8000 as well, structural adhesive, and they were to bond the E-track to the interior sidewall, and just using a couple rivets to hold it and tack it in place while the adhesive cures. So with that, they were able to go from 2 operators to 1 operator for that procedure. They reduced their installation time by over 20%. Also, a significant material cost reduction by eliminating the need for those through bolts, which were pretty expensive since they were pretty hefty. And as you can see, aesthetically, it looks much better as well. And that's a big issue and for especially vehicle manufacturers are the aesthetics. With all the wraps you see now on the side trucks, that's a big profit center for them, so they want to make sure it looks appealing to their end customers. And then finally, this is a Polaris application, a Polaris snowmobile, where they were press fitting clutch bearings And now they are using our LOCTITE 648 retaining compound, which allows them to loosen up their tolerances, so it reduces their machining cost, and they use a combined loose press fit along with a 648 to ensure that the clutch bearing is held in place and also provides a proper seal. All right, now some adhesive terms. First off, adhesive definition itself, I pulled this from the British standards. I thought this was a pretty good definition, and it's defined as a non-metallic substance capable of joining materials by surface bonding or adhesion in the bond possessing adequate internal strength, cohesion. So the key terms there would be non-metallic substance, joining materials, and adhesion and cohesion. So what is adhesion and cohesion? In layman's terms, because I'm not a chemist, but the way I describe it, adhesion is the ability of the adhesive to chemically bond to the surface or part that you're trying to assemble. And I say chemically. You could also rely on mechanically keying into the surface if it's, depending on how the surface finish or roughness of that part. The cohesion is really the strength of the adhesive material itself. And when you're designing assemblies, it's important to know when you're doing some lab evaluation or doing prototyping and you're doing tests in the lab, when you evaluate the failure of your parts, the primary or goal is to get cohesive failure. If you're getting adhesive failure that's failing from the surface, so that's not as predictable once it's out in the field. You want to be able to make sure that you're getting cohesive failure. So again, when you're evaluating your parts, you want to look to make sure you have adhesive. Once it fails, you have adhesive on both parts. That's a good sign. If you have adhesive on one part, typically it tells you may have some type of contaminant, or the surface energy of that adhesive of that part may not be compatible with adhesive. So in those cases, you want to make sure you consult with an adhesive specialist from Henkel or Hisco. Also, the ability to bond to the surface, some key things to understand. It depends on several variables. As I kind of mentioned earlier, surface energy, also surface roughness, surface contamination, and surface wettability. So surface energy, of most metals, those are pretty easy to bond to. We bond well to a variety of plastics, but there are certain plastics that have lower surface energy, like polyolefins, polyethylene, polypropylene. And those are more slick surfaces. So with those, you often need to treat it before you bond it, like either with a plasma or some type of primer, etc. So the importance of cleaning with an adhesive joint, as you can see here demonstrated by this cross section, is you want to make sure you remove all contaminants. Otherwise, it's really a layer between the adhesive and the part that you're trying to assemble, so you're really not bonding to the part. So it's important to make sure your parts are clean. And certain chemistries of adhesives are more robust on as-received parts, and some are more sensitive. So again, make sure you consult with your Hisco or Henkel representative to select a proper adhesive for your parts. And it's always good to know what specific parts you're bonding. For instance, before you approach your representative, they'll want to know specifically what type of metal and specifically what type of plastics you're bonding. Instead of just metal or plastic, they'll want to know if you're bonding a stainless steel to a polycarbonate material, so that way they can better direct you. So that would save you time. And then surface wettability is necessary for good adhesion. And we kind of like to give the analogy here as looking like a waxed car, water on a waxed car. If you sprinkle water in your part and it beads up, you want to make sure that you kind of minimize that surface tension in there, either with a cleaning method or a roughening, so that way the adhesive better wets out. So you want it to be able to wet the entire surface so it provides optimum contact to provide the best adhesion. And then, the adhesive during the adhesive strength is developed through polymerization or polymer building, and it's going from a liquid to a solid, which we call cure. but that is also where they develop chains of adhesives. And typically, you need to allow a certain amount of time for those chains to develop without disturbing it to provide maximum strength of the adhesive. And these chains can either form a thermoplastic or thermoset type of chain, depending on the technology of adhesive that you're using. Thermoplastics are linear chains, where thermoset materials are cross-linked and tend to be more robust. Those tend to be more like your epoxies, your acrylics, some of your two-part urethanes, more structural type adhesives. So there's some basic terminology that you'll encounter when you're selecting adhesives. So now I'm going to turn it over to Daryl Small, who will talk about joint designs.
Thanks, Mike. This slide here basically shows that there are 5 different types of stresses which can be applied to a bonded assembly. The reality is that there's very few applications in which the adhesive is constantly under compression and compression only. Similarly, there's very few applications where the adhesive would be under complete tensile stress only. Most applications have either a peel point where the adhesive can start to give out and start to unzip, or they have an overlap type of bond where it's a sliding type of motion or a torque or a twist, where essentially the strength that you're looking for is high shear strength. These 3 diagrams basically mean to show that when it's under compression or tension, all of the available surface area is being utilized. Your force is being spread out across that available surface area as evenly as possible. When you have a shear type of motion or a sliding or a twisting type of motion, the stress is going to be concentrated at the ends or the edges of the bond line and then slightly less towards the middle. On the other hand, parts that are either flexible or rigid parts that are subjected to some type of a point load, perhaps the best analogy would be a screwdriver shoved between 2 bonded pieces and used to pry it apart. That would be a cleavage type load. Well, as you can see, in these types of circumstances, the stress is being concentrated at the edge of the bond area, and once that gives out, it opens up the next edge of the bond area to come apart, and then propagates from there. So the summary of bond joint design is that you want to minimize any peel or cleavage type of forces, and you want to try to maximize the shear, tension, and compression type of forces. When we test adhesive applications, there's basically 3 types of failure that we are looking for. Once we allow the adhesive to fully cure and we do some type of a destructive test on the bonded joints, the first thing that we definitely do not want to see is adhesion failure. That would quite obviously be an inappropriate adhesive candidate for that particular assembly. Underneath that diagram on the bottom left of your slide, you see where it says cohesion failure. In this case, the adhesive has not debonded at all. In fact, the adhesive residue is still stuck to both adherends or both substrates, and you have simply compromised the cohesive strength of the polymer matrix that is the cured adhesive. That is traditionally the most desirable type of bond joint failure when doing a destructive test. There are, of course, some applications where the pieces themselves will actually crack as opposed to the adhesive, where the piece itself will break as opposed to the adhesive breaking. Common examples would be things like glass or paper and fabric or neoprene rubber or EPDM rubber, and some of the very easy to bond plastics. The adhesive strength is so high that you end up cracking and tearing apart the substrates themselves when you destructively test them. And of course, there can be a combination of adhesion and cohesive failure. However, you should be looking for a dominant cohesive failure with minor evidence of adhesion failure to the substrate. This slide is simply meant to show that there are very simple geometric ways to increase the bond integrity. Each of these joints, except for the one on the top right underneath, that's simply a butt joint, two points basically right together. All of the other alternatives are superior to that because in that particular case you have very little flexural strength. All of the others have augmented the bond joint design by increasing the area, by changing it to shear type of motion, and eliminating potential peel and cleavage failure points. These also are some alternatives to existing designs that may be subjected to a peel or a cleavage type of force. You can modify those by adding pieces to augment and to stress relieve those points that would be subject to the peel force. This is one of the common questions that we ask in our seminars and training schools. If you have a bond joint that is 1 inch wide with a 1 inch overlap, then perhaps obviously that is 1 square inch of bond area. On the other hand, if you have a bond joint that is 2 inches wide and 1/2 inch overlap, that also is 1 square inch bond area. The question is, which one would be stronger? The answer is that wider is always better. Again, this goes back to the concentration of the force at the edges of the bond area depending on the direction of the force. So as opposed to having a 1 inch wide bond joint to resist the force being exerted to it, you would want to have a 2 inch wide bond joint. Wider is always better. One of the advantages of using adhesives, and one of the essential ways that adhesives work, as Mike mentioned earlier, is it's a relationship between wettability and surface energy. If you have the adhesive able to get a good intimate contact with the substrate that it is going to bond, in other words, there are no air bubbles and there are no gaps underneath that liquid, the liquid is in complete contact with the surface to be bonded, that's where you get your optimum bond strength. And of course, most adhesives are liquids, pastes, or something in between. So it's oftentimes the surface energy, not the viscosity, that dominates the performance of adhesion and the wettability of the adhesive. To summarize joint design as the summary guidelines, you want to maximize shear, tension, and compression because they distribute the forces as much as possible over the bond area, whereas you want to minimize peel and cleavage where it concentrates the force at a very narrow area. Oftentimes, minimized gap thickness or a nice thin layer of adhesive is the strongest, although there are exceptions to that rule. Wider bond areas are better than additional overlap because, again, you're distributing the force across a wider width. And of course, you have to use the appropriate type of test to qualify your adhesive. Now we're going to get into the adhesive types. So, structural adhesives, instant adhesives, machinery adhesives, which are the classic LOCTITE trade name from way back, and of course bulk adhesives, which we lump together, hot melt adhesives, solvent-based adhesives, water-based adhesives, things of that nature. Epoxies are probably one of the oldest type of adhesive technologies available. Most epoxies are very rigid with outstanding chemical resistance. Not all epoxies, of course, are very rigid, but they are characteristically stiff, high modulus, high chemical resistance, high temperature resistant materials. Acrylics have a slightly more flexible backbone than epoxies. They exhibit good chemical resistance, and they're also very high strength materials. Polyurethanes are characteristically flexible. They have good weathering resistance, and they also have good chemical resistance. Some formulations can actually be characterized as high strength, although many formulations would be characterized as moderate strength. Epoxies, acrylics, and urethanes usually comprise the bulk of what we would consider structural adhesives that are able to generate at least 1,000 psi in a shear strength test. Over on the right, you see silane modified polymers and silicones. Both of these materials are inherently flexible. Silicones, of course, have the most wide temperature range. They have great chemical resistance when it comes to polar solvents, but not so good with non-polar. Silane modified polymers are very flexible adhesives with very good UV and weathering resistance, paint compatibility, which silicones would not be able to claim. However, their temperature rating is much lower than silicones. Silane modified polymers are good to approximately 200 degrees Fahrenheit, sometimes up to 250 degrees, whereas silicones are good to 400 degrees Fahrenheit, and many are good to 500 or even 600 degrees. Instant adhesives are often called cyanoacrylates, but in this category we've listed both cyanoacrylates and light cure simply because of the speed. Cyanoacrylates can be used for virtually anything. The only substrate that we recommend you do not bond with a cyanoacrylate is glass. The reason is because at best it is a temporary bond. It does not last forever. Light cure adhesives can be acrylics, they can be urethanes, they can be cyanoacrylates, they can be epoxies. Light cure is not a chemistry. Light cure is a curing mechanism that can be added to different types of chemistries. About the only limitation with light cure is you have to be able to get light to the adhesive so that it can cure. You couldn't use light cure to bond two pieces of steel together because you can't pass the light through the steel. However, if you had a semi-transparent material that you wanted to bond to the steel, then you can get light through that material. I had mentioned earlier the machinery adhesives, the classic LOCTITE anaerobic line from decades ago. These types of materials can be used for locking threads, they can be used for mounting bearings on shafts, they can be used for locking and sealing pipes, they can be used for sealing and locking flange gasket assemblies. All of these materials are designed for use on metal assemblies that are essentially mechanical assemblies to begin with. For instance, a nut and bolt is a mechanical assembly. A bearing on a shaft is a mechanical assembly. Threaded pipes are mechanical assemblies. But we're augmenting the seal and we're increasing the pressure resistance and we're increasing the long time performance with the anaerobics. Another major advantage of anaerobics with all of these applications is not only do they seal, but they protect from corrosion. In fact, most of our adhesives can be said to protect from corrosion in any of the applications that they're on because they are a polymer that is going to prevent water and moisture from entering the assembly and causing oxidation to occur. Many times when we disassemble parts that have been aged and have rusted, you will see that there's very little rust evidence inside where the adhesive was present. Finally, bulk adhesives I mentioned earlier, hot melts, one-part polyurethanes, solvent-based materials, water-based materials. These are typically relatively lower viscosity types of materials because they're being used on a very large scale. Sometimes they will be applied with heated applicators, and of course there's many other applications where they can be made into sprayable formulations for large area coverage. In our adhesive source book, in one of the first few pages of the adhesive source book, we have two charts. One of those charts we call performance considerations, and in this chart we show each of the 8 basic types or general types of adhesives. And we start out with the primary row of information you're going to see is the temperature resistance. So this gives you the typical for the category and then the maximum for the category. Temperature is oftentimes an important selection criteria in deciding which adhesive is going to be used. Although there are many applications where the parts, once they are bonded, they are simply on earth at room temperature, whatever that might be. It may be very cold, it may be very hot, it may be very windy, or very harsh outside, but essentially they're far below 200 degrees Fahrenheit, worst case scenario. Almost all adhesives are going to be able to perform within that envelope. If you're using things on a car where it gets up to 300 degrees Fahrenheit, or some type of machinery that gets up to 350 or 400 degrees, then it limits you to some of the more robust candidates like epoxies and acrylics and silicones. On this same chart, you'll see that there's a general rating for the type of adhesion to different substrates, the 5 basic types of substrates being metals, plastics, glass, rubber, and wood. There are, of course, an infinite variety of metals, plastic, glass, rubber, and wood. However, this gives you a general idea of which types of chemistries would be appropriate test candidates for the application at hand. In addition to the performance considerations, we want to talk about process considerations. Mike had mentioned earlier that one of the limitations of adhesives compared to mechanical techniques is that they must cure. They're not instantaneous. Even our instant adhesives require a certain number of seconds before they have cured. In addition, many adhesives have a certain amount of time that's required to reach what we call fixture cure, enough handling strength to be moved on to further points within the manufacturing process, or indeed sometimes to be put right into service, into the full service for whatever that device is. So the fixture speed is often the most important criteria for selecting your most process-compatible types of adhesive chemistries to keep up with your production rate. So now I'm going to talk about the primary adhesive selection criteria. We do not consider it a lottery. We do not throw darts or play roulette. We're looking for significant customer input so that we can basically understand 4 concepts fully and completely. The first one is we want to understand what you are bonding. It's not just metal and plastic. It can always be more specific than that. We could even ask questions about surface finish, cleanliness, processing residues that may be present. That's the substrates. We also want to know how this part fits together, what the geometry is, whether it is a nut and bolt. If it is, what are the threads? If it's a mechanical, if it's some type of a box, how big is the box? What does the bond area look like? How wide is it? Is it a tongue and groove design? There's a myriad of geometry questions that we could ask. So number 1, we ask about the substrates. Number 2, we ask about the geometry of how they fit together. Now we have a picture of what the device is. Third thing we need to know is where that device is going to function during its life cycle. As I mentioned earlier, if it's simply outside, that's a certain environment. If it's on a car, that's a very different environment. If it's underground on some type of equipment that is maybe used in mining, that's a different environment. It can be underwater applications. And then finally, the last question after we understand the substrates, the geometry, the environment, we need to know how many you have to make. If it's 1, then we have a lot of options because fixture speed is not really an issue. However, if it's 1,000 parts per day, then fixture speed is going to be a major selection criteria in deciding what the appropriate adhesive would be. So we're looking for a significant amount of customer input to tell us what you are trying to do. We then take that information. We go through the adhesive selection exercise that helps us select the appropriate adhesive test candidates for your application. We may also have several variables that we study in order to understand how robust your manufacturing and assembly process will be. Here's a list of some of the questions that can be generated when we are asking things about the substrates, the geometry, the environment, and of course the process considerations. One of the things that I like to point out here that is most important is what is the package size of adhesive that you are going to purchase it in? Is it in a syringe? Is it in a cartridge? Is it in a liter? Is it in a pail? The package size is going to define how long that package size will be in process or being used in production. It also tells you what type of flow rate you need to achieve for your application itself. So the package size is a major consideration for deciding what is process compatible. Here's an example of one of our most popular instant adhesives, cyanoacrylate LOCTITE 401. LOCTITE 401 is a water-thin viscosity, very fast fixturing cyanoacrylate adhesive, which again sticks to virtually anything except glass. On this tech data sheet, you will see basically 4 different categories of data. Uncured properties, the liquid properties, curing properties like fixture speed, cured completely properties like lap shear strength and block shear strength, and of course the final thing would be the environmental resistance and heat aging and chemical and solvent resistance, so that we can gauge the long-term durability of the adhesive for your application. These are some of the properties that are almost always listed on our technical data sheets. Some things wouldn't apply. For instance, a sag property wouldn't apply on something that's a wicking grade material. However, for many applications that require a putty or a paste type material for vertical applications or for smearing where you do not want it to run down into other undesirable areas, then you would want a non-sag material. Working life and fixture time are closely related. What is the amount of time that you can utilize the adhesive? How long can you dispense the adhesive and have it remain usable before you assemble the parts? That's a working life question. Fixture time is once you've assembled those parts, how long does it take before it's going to be handleable, before it's reached enough strength to resist gravity and minor forces and stresses that would be associated with handling. There's a variety of cured material properties that you will find on our technical data sheets as well. After all, most of the products that we are talking about are polymers. They are acrylic-based polymers or urethane-based polymers or epoxy-based polymers, etc. I had mentioned that package size is an important consideration for your process. That goes along with dispensing equipment. There are many applications where manual dispensing is fully suitable for the application at hand because there is sufficient labor available. It's very easy to do. On the other hand, there's plenty of applications where a robot offers quality and precision and precise adhesive dispense and minimal waste because you have a controlled dispense onto a relatively more complex piece. And of course, we have a full range of fluid delivery equipment for all of our adhesives, whether they are anything from a low viscosity liquid up to a high viscosity paste and anything in between. And of course, we sell a full line of light cure equipment for our light cure adhesives. So our final polling question is, would you like some professional assistance with your adhesive application or process through Hisco and Henkel LOCTITE? Let's see how we do on this polling question. Well, we had hoped that it would be 99% yes, please have a professional contact me, but as we expected, about half of you are here for information purposes. All right. When it comes to equipment selection, I think I've already talked about this. You know, you need to understand the adhesive chemistry, and of course you need to know what package container that adhesive is going to be in. And then several other questions can be asked after that to help us qualify that we have selected the right size container so that you can consume it within an appropriate amount of time. You certainly wouldn't want to be replacing the container every hour. You would probably want to replace the container every shift or maybe every day or so. Here's a couple of the Henkel adhesive resources you find online. On our website, we have the adhesive source book, which I've referred to a couple of times. Although I haven't mentioned it before, we have 3 publications: the plastic bonding guide, the rubber bonding guide, and the metal bonding guide. These 3 publications are invaluable in looking at the types of chemistries that exhibit good adhesion to those types of plastics, rubbers, and metal versus the types of chemistries that you might want to avoid for those types of substrates. And these are also, of course, available from your Hisco branch and your Hisco rep. In addition to our website, we take hundreds of calls at 1-800-LOCTITE, 562-8483. Our technical information team is on hand to answer virtually any question you can have about adhesive selection and adhesive dispense equipment recommendations. And of course, we do have our field sales force along with the Hisco distributor partnership. I work in our technical customer service application engineering department here in Rocky Hill, Connecticut. We do we do thousands of laboratory projects per year, and we also do many process development and special equipment builds. Here's a view of our website at www.loctite.com, which points out some of the additional resources available. For instance, you can get TDSs and MSDSs. There are some how-to videos, and of course we have a link to our literature with various case histories, quality certifications, and multiple different brochures and design guides. So when you are considering an adhesive and sealant supplier, we'd like you to consider Henkel. Our breadth and our depth of product offering is unmatched. We're the largest adhesive supplier in the world. We have unparalleled technical service and sales support around the world. Our quality standards and adhesives and industry certifications, our testing capabilities, of course, our global reach. Along with our testing capabilities comes our process knowledge, particularly with dispensing equipment, and our industry expertise focus on innovation. And of course, our overall value offering, we are looking for a solution that is going to save you money, save you time, make you a higher quality, more consistent product. And that is our webinar on designing with adhesives. I'd like to thank Hisco for organizing this. It's been our pleasure to be the facilitators today. We have a few minutes left for questions and answers, so please use your chat feature and we will go from there. All right. One of the questions that we oftentimes get is, what is the highest temperature rated adhesive offered? In our adhesive source book, you will see that our silicone adhesives offer the greatest temperature resistance. I think we have 1 or 2 that are rated to 700 degrees Fahrenheit. Another question we often get is, what kind of shelf life do adhesives have? Now, of course, there are exceptions to this rule. However, most of the products that we sell are going to have 1 year shelf life from the date that you receive it. Sometimes it will be less than 1 year. It will be a certain number of months, depending on the complexity or the sensitivity of that industrial product. But most adhesives are good for 1 year, and every container we sell should have a clearly readable use-by date underneath the batch code.
Great, and we did have a couple of questions come in here the last second or two. First off is, where can I find a selection chart for adhesives?
Well, in terms of a selection chart, we usually refer to our performance and process considerations tables in our adhesive source book. Now, of course, within each section of the adhesive source book, for instance, for epoxies, there is a selection chart for different types of applications. Similarly, there would be one for our cyanolates or for our silicones. There's a master selector chart for the type of chemistry, and then each type of chemistry within the adhesive source book would have a follow-up selector chart.
Great, thank you. The next question that came in here is, my needs really apply to working with glass. I need an adhesive that doesn't dry too fast because it needs time to sink in between very small spaces. And it needs to remain clear and hard when dry because it will be sanded and polished along with the glass. Is there something you can do to help me?
Well, that's a complex need. We do have a large number of adhesives that are well suited for bonding glass and exhibit exceptionally high bond strength. However, a lot of these adhesives would be kind of a pale yellow color, unless, of course, they're in a very, very thin film, and oftentimes that pale yellow color is so faint that it really appears optically clear. We can't say that we have a true crystal clear adhesive. They always have some type of a pale yellow appearance to them. For your particular application, given your requirements for not only the good appearance, but the ability to shape and sand and kind of machine the adhesive surface, I would use our E30CL epoxy. Oftentimes our light cure acrylic urethanes are somewhat soft, and they don't respond too well to abrasion. You know, they get kind of dull, so to speak. So I would normally recommend our Hisco E30CL clear epoxy, which is an exceptional candidate for bonding glass. It has a long open time, long working life of about 30 minutes. It should work very well for your application. The only challenge, I think, or the biggest challenge I'm going to say with your application is the need for the wicking, the very low viscosity. E30CL is several thousand centipoise. I'm not sure that it will work very well. However, a little bit of heat, a couple little heat experiments, I think will tell you a lot about whether or not it is feasible. If that doesn't work out, we do have a wide variety of very low viscosity light cure acrylics. I'm just worried about their sanding and shaping ability. And of course, you know, when you have a light cure acrylic, it's unlimited open time until you show the light to it, and then it's over. It cures very, very quickly. I hope that was helpful.
Great, thank you. And now back over to Daryl.
All right, well, we just wanted to thank you all for submitting those questions. Thank you all for attending the webinar today. We hope that it was helpful. We do appreciate Hisco once again coordinating the effort here, putting the webinar together, getting the word out to all their customers. And if you have additional questions or need additional information, please reach out to your local Hisco branch or call 1-800-LOCTITE for more information. And I'm sure the Hisco people will be following up with you shortly. Thanks again and have a great day.